So let's talk about virtual machines. And one thing that you are going to want to know is how a virtual machine works and what a virtual machine is. A virtual machine is a software application that simulates a computer but hides the underlying operating system and hardware from the programs that interact with it. If the same VM is implemented on many computer platforms, applications written for that type of VM can be used on all those platforms. You could have Windows, Linux, Mac, or really any operating system. If you look at this diagram here, you can see that each operating system has its own virtual machine, and the JVM is one of the most widely used virtual machines. But if you look at the top there, you have your original Java program, which is simply a list of unambiguous instructions that are created by a developer with a text editor or a visual programming tool and then saved in a file. This file is said to contain the source code. It is now ready to be compiled with a compiler, and the resulting output, the compiled file, is often referred to as an executable machine language program. But in Java, it is an executable machine language program for a computer that doesn't really exist. This so-called virtual computer is known as the Java Virtual Machine, or JVM. The machine language for the Java virtual machine is called Java bytecode. There is no reason why Java bytecode couldn't be used as the machine language of a real computer, rather than a virtual computer. But in fact, the use of a virtual machine makes possible one of the main selling points of Java: the fact that it can actually be used on any computer. All that the computer needs is an interpreter for Java bytecode. So your source code is compiled to bytecode rather than machine language. The same bytecode instructions can execute on any platform containing a JVM that understands the version of Java in which the bytecodes were compiled. Here's the software stack that is used runtime. You start with the operating system. You can run Java applications on Windows, Mac, Linux, or really any operating system that implements a Java virtual machine. The Java virtual machine, or JVM, that you use most of the time will be the one provided by Oracle that was originally created by Sun Microsystems. But there are other JVMs out there, including one provided by IBM and one that is provided for Android by Google. And there are basically many others. And on top of the virtual machine, you add the core runtime and additional libraries. The core runtime is sometimes called the Java class library. Java class library is a set of dynamically loadable libraries that Java applications can call at runtime. Because the Java platform is not dependent on a specific operating system, applications cannot rely on any of the platform native libraries. Instead, the Java platform provides a comprehensive set of standard class libraries containing the functions common to modern operating systems. And we will get a little bit more into more details about libraries a little bit later in this module. Finally, your application is compiled into bytecode, and that bytecode runs on top of all those other layers. So, a little bit more about the JVM now. In early Java versions, the JVM was simply an interpreter for Java bytecodes. Most Java programs would execute slowly because the JVM would interrupt and execute one bytecode at a time. Some modern computer architectures can execute several instructions in parallel. Today's JVMs typically execute bytecodes using a combination of interpretation and so-called just-in-time compilation. The other important thing about the JVM is that JVM does garbage collection, and I'm not going to go into details for now in garbage collection, but garbage collection is basically a way to reclaim memory occupied by objects that are no longer accessible to a program. It is JVM responsibility, not the programmer, to keep track of which objects are garbage. In many other programming languages, it is the programmer's responsibility to delete the garbage, and unfortunately, keeping track of memory usage is very error-prone, and many serious program bugs are caused by such errors. A programmer might accidentally delete an object, even though there are still references to that object. This is called a Dangelin-Poiter error, and it leads to problems when the program tries to access an object that is no longer there. But because Java uses garbage collection, such errors are simply impossible. Garbage collection is an old idea and has been used in some programming languages since the 1960s. Also, a JVM is going to do things like verify that the code doesn't violate its memory or address spacing, that it is not going to be able to just access some random part of the operating system. Things that are running inside the JVM are sandboxed. They have that safety because a program running in a virtual machine is far less likely to disrupt the user's operating system or corrupt data files if errors occur. That's basically it, and this is almost the most important things that a Java developer needs to know about the JVM. So now let's go ahead and jump right into creating our first Java application.